All right. So basically what I want to focus today on is with the differentiation paper. I'm only looking at parametric equations, all right? So the next series of 6 questions that we've got today, it's all about parametric equations. Now I think had Mr. Johal talked to you guys last term about it, like even just differentiating it, just one of those equations, you can get it achieved. But the reason I chose parametric equations today is because it covers quite a bit of different types of differentiation that you should be comfortable with. So this question here is from 2017. And what I would like you guys to do is actually work out the answer for this. And I'm going to give you guys about 2 to 3 minutes. And then I'll go through the answer. All right?
Okay.
Now, even if you, how do I say this? Even if you're not sure what to do, you should be able to at least differentiate those 2 functions. Okay, so what you want to be doing is you want to actually differentiate x with respect to t and differentiate y with respect to t. So I'm going to rewrite x as t plus 1 to the power of half. And then when I differentiate dx dt, I get half t plus 1 to the power of negative half. Now this is the part where people forget, and I know in this case you might be lucky, you don't have to worry about it, but I always get into the habit of multiplying by the differentiation of whatever's inside the bracket. And in this case, it's 1. Now I know you don't have to do it, but just get into the habit of it. Because when you get like 2t plus 1, then you won't forget that little 2 that comes across, okay? So I've got my dx dt. Then on this side I've got y is equal to sine of 2t. So dy dt is going to be differentiation of sine is cos. So I've got cos of 2t, and that's multiplied by the differentiation of whatever's inside the bracket. In this case, it's 2. So I've got dy dt, I've got dx dt. They're asking for the gradient when t is equal to 0. So what you're looking for is, you're looking for dy dx when t is equal to 0. Now, whenever you do parametric equations, guys, get into the habit of writing dy dx. So I would write this as dy dx is equal to dy dt multiplied by dt dx. So in this case, dy dt is 2 cos of 2t multiplied by dt dx. Now, if you are not comfortable with moving fractions or moving negative powers or anything like that, just do this. Rewrite this as 1 over half t plus 1 to the power of negative half. If you're uncomfortable doing this, but if you're comfortable, then you know that if I write it like this, you'd be fine with it as well. So if I write this as 2 t plus 1 to the power of positive half. Okay, you don't need to do this. You can actually stop in that line there. Once you do that, yep.
Doesn't matter if it's dy dx. Can it be dx dy?
No, can't be dx dy, because that will not be giving you the change. You're actually finding change in x over change in y, which theoretically is not what gradient is. It's rise over run. What you've just done is run over rise. Does that make sense? Sweet. So now that we know that t is equal to 0, in this case, we're lucky because we can just go, well, actually, I'm just going to put this as when t is equal to 0. So I've got 2 cos 2 times 0 multiplied by 1 over half times 0 plus 1 to the power of negative half. Now, in this case, we're lucky, guys. I don't think you actually need to use the calculator, because what you're going to end up with is cos of 0 is just 1, and then you got 1 over half. 1 to the power of negative half is just going to be 1. Okay, so this answer ends up being 2 times 1 times 1 over half, which equals to 4. All right. As I said to you guys, just dx dt or dy dt gets you an achieved. All right, just one of them. But to get a merit, you got to get the full answer, which is 4. Okay? All right, so we go to the next question. As I said to you guys, we're going to be working on all to do with parametric equations. So this is from 2016. There you go. This is from 2016. I'll give you guys a bit of a heads up. Make sure your calculator is in radians. That's hint number one. Number two is be careful with dy dt because you have to use chain rule for that. That's all I'm going to tell you guys. Have a go. Yeah, something like that. I can't do it in my head, man, unfortunately. I'll do it slowly, all right? So we got dx dt first. Okay, no, I'm going to write x is equal to 2 cos 2t. So dx dt is going to be 2 multiplied by negative sine 2t multiplied by the differentiation of this, which is 2. So if you get this, which is going to be negative 4 sine of 2t, is that all right? That's dx dt. Okay, now with y, make sure you guys write, whenever you see tan squared, sine squared, cos squared, and you got to differentiate it, make sure you write it like this. Then that's how you'll remember that you got to use the chain rule for it. So when you write it like this, y dash becomes 2 multiplied by tan t to the power of 1, and then that's multiplied by whatever the differentiation of inside the bracket is, which is sec squared t. I shouldn't have put that as y dash, I should have put that as dy dt. Is that okay? Now, the thing is though, I wouldn't actually mess around with this. I'll just leave it as it is and probably just use one step at a time. So we've been asked to find the gradient at pi over 4, am I correct? So then dy dx equals dy dt multiplied by dt dx. So we have dy dt is 2 tan of t multiplied by sec squared of t divided by negative 4. Yep. 2t. Is that okay so far? Yep. Okay. So we now have to substitute pi over 4 in here. Now, you guys can't do sec squared t in your calculator, am I correct?
Yep.
So what is sec theta in terms of cos theta? 1 over cos. So what I'm going to do is I'm going to rewrite this whole equation as 2 sine t negative 4 sine 2t multiplied by cos squared t.
Are you not recording?
Yeah, sorry guys, might have skipped a few steps, but you get the idea. Just follow the instructions. There's the differentiation.
Teaching 101.
And then, okay, where was I up to?
You're plopping it in the calculator.
Dropping in my calculator. It sucks. Okay, where was it? I was in radians, that's fine. Go into run menu. I gotta write this. So I'm gonna put pi over 4 as my answer. Just because I don't want to keep typing pi over 4 all the time. So then in my top bracket, I've got 2 times tan of answer divided by negative 4 times sine of 2 times answer multiplied by bracket cos of answer squared. Hopefully that's enough brackets. That looks all right. So what have I got? I've got my answer as negative 1. What do we got here? Yep. Looks good. So as usual guys with this question, correct dx dt gets you an achieved, or dy dt gets you an achieved, and getting that -1 as your gradient gets you a merit. That all right? Now look, the calculator instructions, you don't have to do it in one whole line like this. If you are nervous about it, just do it one step at a time. Okay? Just do it one step at a time. It should be fine. You guys okay? Oh, you got a different answer? Yeah, just, if unsure, it's just making sure that you're putting the brackets in the right spaces, that's all.
Programming 101.
All right, we go to the next question, guys. What's our time limit today? We got... Yep, we should be fine. We're going to start speeding up things, guys, so...
You just skipped the answers on this one too.
No.
Guess we have to learn.
This is slightly different, this question, because you've got to find the gradient first, and then after that you got to find the normal. So here we go, folks. Nice simple one. This one I'm going to give you only 3 minutes for the whole question. Go.
Guess they added me on LinkedIn.
By the way, that's 2015 question, this one. Okay, so we've got x is equal to 3 cos t, which means dx dt is equal to -3 sine t. I don't have to worry about multiplying by the bracket in this case, so just leave it as it is. And if y is equal to sine of 3t, then dy dt equals cos 3t multiplied by the differentiation of the bracket, in this case, which is 3. So, then dy dt equals 3 cos 3t. What am I dividing by? Okay, let's see. dy dx is equal to dy dt multiplied by dt dx. So we got 3 cos 3t times 1 over -3 sine t. Is that all right so far? Yep. Gets rid of it. So we got cos of 3t divided by sine of t, but of course there's a negative there. Now we did pi over 4, is that correct?
Mm-hmm.
Okay, so t is equal to pi over 4, which means we got cos of 3 times pi over 4 divided by minus sine pi over 4. So, let's see. That's pi over 4.
Yes, all the
So I've got cos of 3 times answer divided by negative sine so 1? Is that the correct answer? So dy dx at t equals to pi over 4 is equal to 1. Is that correct, folks?
I got -1.
Why?
I don't know.
You got answer as -1.
Yeah.
Okay. Well, what is the question actually asking us? Let's go back to the question. The question's asking the gradient of the normal, which means
The other line.
once you find the gradient, to find the normal, you got to go -1 over the gradient that you just found.
Am I doing something wrong?
-1 over 1, which
We are
means
doing
your answer is actually
what I got.
-1 is what I was looking for.
Let's
Hold on, let me have a look at this. Give me a second. Just sorry? Did you do that step, Joe? The -1 over m?
No, I just got -1 from.
Can I have a look? Hey?
I didn't get a 1.
I got 1 point.
Yeah, I think I know why you guys got that. Because you guys forgot the 3 times pi over 4. Look at your, Joel. You forgot 3 times pi over 4. Did you do cos pi or did you do cos of 3 times the answer?
3 times the answer.
Hey,
Yeah,
that's
you got to do cos of 3 times the answer because it's 3 pi. Look. It's not cos of t,
Just add a bracket though.
it's cos of 3t. So you got to go 3 times the answer.
Oh, Oh, we just didn't add that bracket.
Yeah, but that means you would have got a normal gradient of +1 then.
How did you do the
Which means you would have been incorrect. So even if you put -1 from that wrong answer, you're still incorrect. Yep, I think I know what happened. All right, this one. This is a proof question. It's not even a find the gradient. You just got to prove it. Guys, I'm going to give you guys a hint for this particular question. You need to use page 4 of your formula sheet.
Perhaps 4.
Yeah, that's the hint for you. Yeah, I heard the trig identity somewhere. Okay, this is the first part I'm going to do. So you got x equals to 2 sine t, then dx dt is 2 cos t. And if y is equal to -2 sine t, then dy dt equals -2 cos t. Is that correct?
No,
-2 cost.
is y is equal to cos 2t.
Where have I made my mistake? Oh, sorry, cos 2t.
Y
Sorry,
is
I
equal to
copied the wrong
cos
one.
2t.
Yeah.
My bad. Yeah, I realized where the mistake was. I actually differentiated this thing. Sorry. Thanks for telling me, guys.
It's Gucci.
Y is cos 2t.
Yeah.
Okay, so then dy dt is negative sine 2t multiplied by the differentiation of that, which is 2. Is that all right?
Yeah.
So we got dy dt is -2 sine 2t. Cool. So we are trying to prove dy dx is equal to -2 sine t. Am I correct?
Yep.
Yep.
Okay. So we also know dy dx is dy dt times dt dx. So that can be written as -2 sine
Oh, I get how to do it.
2t divided by dt dx is 2 cos t. Now let me ask you guys this question. How are we going to go from this to this?
Double angle.
Yeah, double angle. Because the thing is, what you want to get rid of is this sine 2t. All right, you got to get rid of that because you don't actually have any of that on dy dx. So if you go to your formula sheet, double angle right there, which is equal to 2 sine a cos a. So that means we go back in here and we can write that sine 2t as 2 sine t cos t divided by 2 cos t. And at this point, cancel that. Those and those two things cancel. 2 and 2 cancels. And you're left over with just -2 sine t. Okay?
Wow.
So, when you guys get a proof question, go to page 4. Okay? Because if they're asking you to find the gradient, then you're going to use a calculator. You don't really need to worry about the double angle or the identities at all. But if they ask you to prove anything in the paper, go to the page 4 and look for the identities that you can potentially use. All right? This, I would actually say, yeah, this was a merit question from 2014. So you'd have to finish it off to get a merit. All right, the final
Why are
step.
these things
But I
in the
think
thing?
dx dt or dy dt should be
Well,
achieved.
what if you have 2 triangles on?
I don't know what that means.
All right, next question. This is the last one for today's question. We have...
Probably you got this. Gotta give Avi that motivation. He's not gonna do
Please
it.
don't. I was like, I don't want motivation right now.
Especially not from him.
Yeah, I know from him.
Just have a Barocco. So you can have a big day.
All right, people, there we go.
I just,
This is from 2013, this question. Okay, again, working with... Have you guys noticed how they always have like a trig function in the parametrics?
Yes, it's to bamboozle you.
Yeah, I think it's because they want to make sure that you guys know how to use tan of pi over 3 or something like that. I don't know, man. Who knows? Is it 5 over 24 or negative, Bob? Ooh, is it negative or positive?
Negative.
All right, let's have a look. Let's have a look. So we got x equals 5 sine t.
Can you write in a rainbow?
Right in a rainbow.
Is that
Fine.
a thing?
Yeah, pretty sure.
Do
Yeah,
it for the rest of
that's-
the sessions.
Okay. So then dx dt is equal to 5 cos t. It just looks so colorful, eh?
Yep.
How to get the kids to like nuts.
What, write in rainbow ink?
Yes.
That looks awful. Like the T looks weird.
Orange and green.
Yeah, you can't.
Okay, what was that?
literally our
No, I
colours.
can't actually focus on it, eh?
It's literally our colors.
Okay, dy dt is, what's it going to be?
Something.
3 sec squared t?
Yep.
Is that alright? Okay, how many of you guys did this? I just wanted to double check.
Oh.
Did you guys do dy dt equals, sorry, dy dx, isn't it?
Yes.
So dy dx is dy dt times dt dx.
Yes.
So this is going to be 3 sec squared t divided by 5 cos t. Does that look alright?
Yep.
Yeah? Okay, now here's the question. Why can't you just do this? Because I know you guys probably can go in the calculator and go t is equal to pi over 3 and do that thing again. But like, why can't you just do 3 over 5, like 3, 5 like this, cos t, and you know how sec squared theta, if it's in the numerator it's sec, but then if you bring it to the denominator, becomes cos squared t. And then this could be written as 3 over 5 cos t to the power of 3. So, if I go into my calculator now, 3 divided by 5 times cos of...
Oh, we're charging Matt.
$1,000. Hey, I like how you helped me. $1,000. Wait, was that recorded?
4.8?
Yeah.
You should have got 4.8, no matter which way you do it. That's the gradient.
Which is incorrect.
But, what?
Yeah. What?
Yeah, 4.8. Isn't 4.8 24 divided by 5?
5 over.
So, the normal gradient
With the other
is
side.
going to be negative 5 over 24.
Yay.
Flip it. Sorry?
You go
Because
over-
remember, it's negative 1 over m for the normal gradient. That's why you forgot the negative, man. You just flipped it.
You know why I stopped paying attention? Because it's not in rainbow ink.
Okay, just for you there.
See, that looks good.
Yeah. I'll even do one better. Lava ink.
I like
That.
Okay?
What other ones are there?
No, we're not doing this, okay?
What's that one?
What about the?
Oh my
the blue
god.
one?
There.
Yeah.
This is what I have to deal with there.
It's the same thing.
It's the same thing with a slighter shade.
If you color.
No, we're not doing. No, we're not doing anymore.
And then
Okay,
white
look,
with
that's it.
dots on
Okay. Any more questions on this, guys? So with parametric differentiation, all right. When you see it, oi, listen. Kenny. Thank you. What's the right one?
Good.
With parametric differentiation, guys, just make sure you get this question right, because I think this is one of the easiest questions you can get, because the two functions that you generally ask to differentiate are pretty straightforward. And then just make sure you're checking things like whether you're finding gradient of the normal or gradient, or sometimes they might ask equation of a straight line as well. All right. But if they ask you equation of the straight line, then you just got to put t, you got to put t into y to get the y value, and then t into x to get the x value if you want to try and get the equation of a straight line. Yes, I used the lava ink.
You know, Mr. goes live.
Oh, I can't hear him. What is it? Generally, it can vary, man. It could be anywhere between 14 to 15. I think if you get 3 M's, you should definitely get a merit.
I can take that.
Yeah, 3 M5s should be a guaranteed merit. Like, that's pretty sucky if they go like you need 16 points to get a merit.
That would be too high.
Yeah, that's like, nah. I doubt they would do something like that. But then don't quote me on this. Okay,
That
cool.
is recorded.
Yes, I know it's recorded. I will upload this shortly, so thank you.